Okay, so now we're going to get into Unit 8, Part 2. Continue to determine the water content in the wood. So the quality of the wood depends on the water content, so we definitely need to understand, okay, how to play with this content in the wood. So we gotta know how much water content is there in the wood. In order to do that, we have to do measurement. So the first one is we use a moisture content meter to get the moisture content, okay? And the other one we calculate by doing a little experiment. We call that the oven dried method. So they both try to find the moisture content in wood. So the very first one, moisture content meter, to measure the electrical resistance. Then we're going to convert that resistance to the moisture content percent. So it's definitely accurate to about 1%, but because of the high humidity testing location and fog, sometimes that accuracy, can change, okay? But we're aiming for about 1% accuracy. Calculation, we're going to use the oven dry method. So when we go back to all in-person class, we'll definitely do this type of lab, and we're waiting for that laboratory, downstairs laboratory to be finished construction, so we can use the lab space to play with these things, So the calculation step, first you're going to select the sample lumber about 1 inch long. It can be a circle like that. It can also be a just a regular, wood slab about 1 inch long. So this is just a standard. You can also change that, depends on where you are trying to test. Okay. So weight and then record the sample weights. We call the very first recording green weights. And then place that sample in a 215 degree Fahrenheit heated oven and leave it there for 2 hours. Remove it. Okay, don't worry about it's going to burn, it won't burn. Okay, then you're going to remove the baked samples and then wait it again. Heat it in the same oven 15 more minutes. Remove, weigh them, and then record the weights and pay attention to the weights. You're going to repeat that, okay, baking and weighing until the weights do not change anymore. Okay, because of the water evaporated out, and you're going to get the same density. So we call that when the weights do not change, that kind of weight, we call it the final oven dry weights. Okay, so we have two different weights: the initial weight, green weights, and the final oven dry weights. Now we're going to use that in the calculation or equation. So MC percent, that's moisture content percent, is equal to the green weight minus oven dry weight divided by oven dry weight times 100%. So pretty easy to calculate. So here's an example. So the green weight of the sample is 2.50 ounces. So we're going to put it in the green weight. Final oven dry weight is 1.55 ounces. So we're going to put it right there, divided by 1.55 times 100. So you're going to get 61.29%. Okay. So that's the water amount in the wood. Okay. So that's how we test an experiment using the, or you can also use the measurement or sensor meter. Grading. So quality standard, we deal with the grade because we grade them so you can be able to price, okay, price the lumber. So the grade number based on the, again, use. So standards for grading lumber are prepared by, again, the regions. So the controlling, the association, they control their own regions. So you don't want to go across them, just follow whatever they want to do. So all standards conform to two of them. One is American Softwood Lumber Standard 20 to 70, and the National Hardwood Lumber Association standards. Okay. So here you can see the quality labels right there, like that, for grading. Okay, so softwood grades, we have two. One is a select grades and the other one is a common grades. We're going to classify the softwood into yard lumber and factory and shop lumber. So yard lumbers are your boards, your dimension lumber, and the timber lumbers. Dimension and timber we heavily use for structural applications. Your factory and shop lumbers, we make them the windows and the doors, stuff like that. Yeah. So here's a classification or flow chart right there. It's just a common system, okay, for softwood lumber. So you have your factory and shop, you have your yard. And then it's going to go down into structural. We have board, dimension, timbers, Dimension is going to also have a joints, plants, light, okay, framing and tacking. The timber as a beams, okay, and the stringers, your posts and your timbers. Then we have our boards, we have manufactured boards, you have select and common grades, yeah, and then so on and so go on. Each one of them go. Alright. Hardwood grades are based on the visual appearance and size. So we have first and second grade about 80 to 90% clear. Clear meaning like the wood, okay, is free of defects and discoloration. Again, this is my line quality, okay, assurance or systems. So we have to grade them, judge them, and then we also have to inspect them that they are following all the standards and specification. So select grade is about 85 to 90% clear. Common is a little bit low quality because only 66.67% clear. That means 100 minus 66.67 has the defects. Okay. So properties of wood. So we have different properties. Again, woods are cellulose and hemicellulose polymers, lignins. Okay, so make sure you understand the polymer properties. So we don't have no strong atomic bonds. They are definitely non-conductor of heat and electrical energy. And mechanical properties, we're dealing with the strength. Okay, so these are the factors affecting the properties of wood: moisture content, density, and the specific gravity. So density you can calculate, okay, by dividing the weight with volume. So it's just a mass, okay, or weight. This is mass or weight per unit of volume. And density is definitely different, okay, with different species and family or classification of wood. So when you think about the softwood, they're less dense, so therefore they have lower strength, okay, than the hardwood. So here you can see the three different units. So this is what we use in the United States, and that's outside. So kilogram per meter cube. Cube means we're dealing with the volume, okay, unit. Gram per centimeter cube, and then pound per feet cube. Specific gravity is just a ratio. So when you take a look at it here, this divided by that. So your ratios, and here you have another ratios on, okay, inside of the bigger ratio. So it's just a ratio of density of material to the density of water, okay, at a standard temperature. So GB is the specific gravity of wood. WD is oven dry wood, okay, weight of wood. And this one, V, is the volume of your dry wood, and thus the density of water. So we're looking at oven dry weight over volume, okay, of dry wood, and then we're looking at that value over the density of water, and we call that specific gravity. So gravity is nothing but, I just want to review, okay, your physics for you, your G, yeah? G is very important every time you're dealing with your weight, okay? Weight is nothing but your mass, right, time G, so M, and then gravity G. So mg is your weight, yeah? So don't forget your basic physics foundation. Specific meaning like a particular, okay, particular type of gravity. So every time you think about gravity, we're dealing with weights, okay? These weights are, we're looking at over a particular volume, okay? Density, the same thing. That's just a weight, okay, of water over a volume. So we're looking at the weight over volume. This one, the same thing, weight over the volume. This is a calculated, okay, calculated value. So it's like that. PW is just a final value calculated from another ratio, which is the same thing, your weight of water divided by the volume of water. Okay, exactly the same as that. Now we're looking at the weight of oven dry wood, okay, over volume of dry wood, and we're looking at this value over the density of water. So you're looking at the density of dry wood over density of water, and we call that specific gravity. Okay. Just comparing and see how heavy the wood is compared to the water is a common explanation of density or specific gravity. Okay. Specific gravity is just looking at the density of something over density of water, and that's just specific gravity. Okay. But then some student they need to remember, equation. So it's up to you. I don't know. We have to translate between the values of the symbols with the real thing in the world. Okay, so try to get that connection instead of just trying to remember the formula. So if you know what's really going on, you can easily write the equation down. And I want you to get to that state, not the other way around. Right now, you're trying to remember this and then connect to the world. Actually, you have to know what's going on in the world and then write what's going on in the symbol, okay, in an equation. So try to get that, yeah. So when we study at school, we're going this and then connect that to the world. But once you have studied, a lot, it's going backwards. What's going on in the world, and then you're going to write the equation of what's going on in the world and the symbols back. Yeah, it's just telling you what's going on. That's all. There's not a lot going on in the world, by the way. The same thing. All right, so mechanical properties. Getting into it, so they are highly anisotropic. Anisotropic. Some students forget about S right there, and they usually write like anisotropic. So don't forget there's S in there. So they differ greatly based on the direction. Okay. So when you take a look at it, wood has a lower strength with a grain, okay, than across the grain. With the grain. Here, that's across the grain. Lower strength with the grain. Okay, and you have a higher strength across the grain. Okay, so we're trying to get that. What is the grain? Grain is this one, yeah? You can see the patterns and you can try to remember that. We always think like with the grain has a higher strength. Your brain will trick you, but it's the other way around, okay? Your strength is in the width, not the length, yeah? So imperfections such as knots, sometimes you will see knot holes, sometimes you're going to see checks, okay? Those are just like kind of indentations and some holes and things like that. So those are called imperfections, and they definitely lower the strength, okay? So quality is lower if you have these imperfections in the wood. Bending strength is a mechanical property of wood, and it's really important for the structural application, so you definitely need to do this test. So it's a measure of the stiffness of the wood, okay, of the ability of the wooden member to resist loads. Here we're putting a load on top of the wood and see it's going to break. So that load is again applied perpendicular. Okay, so here I'm going to just draw this forces right there, and it's definitely perpendicular to your specimen right there. And this is your longitudinal axis. So the measures of bending strength are the modulus of elasticity, what we usually measure, and then your modulus of rupture, because it's more like a compressive strength anyway. So your force is perpendicular here. Here is your grain direction. Okay. Now we'll be testing. So if you test the grain direction, the same as you're testing the width direction, because width is stronger than the length anyway. So you can get the force, the maximum force, okay, before the wood breaks. So here are the different compression, tension, stresses. And we're putting these different loads on the wood beam and then test, okay, for bending. So here is your central axis of the beam. This is your simple beam uniform load right there. Here is the vertical shear. Okay, see, look at this. It start bending. This is your wood right there, and that's your force. So your force here, you have a deflection right there, bending, and here is your force, and this is your wood. So that's your tension fiber right there, bending here, horizontal shear. Okay. Okay, so here's a table showing the modulus of elasticity for various species of wood. So here we have pine, we have cedar, and then Douglas fir, spruce, redwood. We have hardwood for oak, maple, bark, and ash. So here you can see the modulus of elasticity and PSI unit. Okay, so we can take a look at just they're all the same, zeros in 1,000. And you can be able to see the pattern right here, and the highest one is right here, bark. Okay, followed by Douglas fir, and then we have ash, and then the redwood. Sorry, actually maple, and then the redwood. Okay, so anyway, so you can see according to the PSI values, you can predict the strength of the wood. All right, bending strength test. Here is your instrument. This is from your textbook. So that's your ASTM bending strength test. Okay, and here when you pay attention, you can see the wood right there. Okay, and this is your force perpendicular to your x-axis right there. And here's your wood specimen right here. Pay attention where it is. And this is for your tensile strength. See how we're putting the load, different direction. This is in the grain direction. Okay. And that's for your tensile strength. The other one is compression. So here's a table showing the tensile and compression. So here, compression strength that's parallel to the grain, perpendicular to the grain. And this one is your fiber strength, okay, stress, proportional limit in PSI. And so here are the species of your wood. Again, you don't have to pay so much attention, just pay attention to these values, okay? Don't worry about the fiber stress, just worry about the compression strength, especially to the parallel to the grain, okay? Because you can be able to see. Again, when you look at the data, just look for the highest and the lowest, and then link with the different species of the wood. Again, no need to remember any of that. Structural wood coming for your timbers, dimensional lumber, boards, composite or reconstituted wood products that we usually use for construction. So composite or reconstituted wood products are materials produced by the combine of wood chips or flakes, so we don't want to waste them, yeah? And we're going to use glue as a binder. So formally we call that the polymer-based glue. It's got to be the polymer-based because you're binding the polymers anyway. Wood is a polymer. So we have a structured composite lumber, SCL, and we have a structured panel products, okay? So thus, these are the reconstituted wood products. So we have many classifications for each of that reconstituted wood product. So SCL, we have laminated veneer lumber, LVL. This is your LVL. So what do we bind together? So graded veneers are binded together. Okay, so layers, you can see them. The parallel strand of lumber is a PSL, okay? This again, we're gluing the strips of the veneers. So SCLs are formed by gluing veneers or strands together, okay? Strands of veneers together. Structured panel products, we're going to use them in construction. Plywood, okay, veneers or plies, we're going to glue them. We have two different plywood. One is use inside interior plywood, use outside exterior plywood. Pretty expensive, about like $24 to $36, and some even higher. And we have a non-veneer structured panels, so your waffle boards, okay. Flakes of aspen bonded with resin. This one is oriented strand board, OSB, longer and narrower strand of wood. So that's we're binding this material. Okay, bind or glue the longer and narrow strands together, you get USB. Glue the flakes of aspen bonded with resin. Okay, you're gonna get the waffle boards. And then we also have the veneer particle composite panels. Okay, veneer particles are glued together in these panels. So here's some pictures. So this veneer is created by rotating a log across a blade. So this is your cutting blade right there, and here is your veneer, and this is your rotating log. And just a way of cutting. So we shave it out, shave the veneer and shave from the log, and then glue them. This is just a sample stamp. So that's the first stamp. This is the second stamp for your engineer wood association. It's just a standard stuff that you can be able to read the thickness and the mil number, and then you have your panel grade, okay, and then the span rating, your tone and groove, the exposure durability, okay, classification, and this is your National Research Board report number. So that's how you select the appropriate wood, okay, by reading these stamps. And this is just showing you, okay, your waffle board. So the waffle board looks like that, and then we're gluing the wood flakes and chips together to make a board. Okay, so this is the end of Unit 8, Part 2. It's not that hard, okay? So make sure you do your assignments.